In this video, I will define sine, cosine, and tangent functions and show how they look like. We will talk about defining angles using degrees and radians. I will show you how to convert from degrees to radians and back. I will prove a few basic trig identities. Let's assume that we have a circle with radius r. So it will look like that. And this is r. We measure angle theta between the horizontal axis and the radius r. Now, we need to measure that in positive trigonometric direction, which is, in other words, counterclockwise. Also, we want to define the coordinate of the point on a circle, which is here. This point we will call it A, B. Those are coordinates of the point. Now, if we write those coordinates as Cartesian coordinates, this will be coordinate A, and this coordinate is B. In other words, this distance is B, and this distance is A. Now, different angles could be defined in degrees or radians. For example, here we have 0 degrees, or 360 degrees, or any multiple of 360, positive or negative. But in radians, it will be 0 radians, and also it will be 2 pi radians, or any multiple of 2 pi. For example, this angle will be 90 degrees, and it will be pi half radians. This angle will be 180 degrees, and pi radians. And similarly, here you have 270 and 3/2 pi radian. And that way you can find any angle you want. For example, if you go halfway here, then you need to compute that angle. And that angle will be basically 90 plus 45 degrees, which will be total 135 degrees. The next thing we want to learn is how to convert from radians to degrees and from degrees to radians. Let's say we have angle theta given in degrees. To convert, we need just to multiply by some constant. This constant will be pi divided by 180 multiplied by theta. And then this number will be in radian. Similarly, you can go back and to write that theta in radian is 180 divided by pi multiplied by theta, and then you'll get it in degrees. Another thing we want to learn is how to define sine, cosine, and tangent functions. Those are very basic and they are dependent on A, B, and R that we have defined already. So, cosine of theta is defined by A over R, and sine of theta is defined as B over R, and tangent of theta is defined as B over A. Now, we can define very simple trig identities based only on those definitions alone. Let's say we want to compute sine theta over cosine theta. It will be B over R divided by A over R. So it equals B over R divided by A over R, which is the same as B over R multiplied by R over A, which is B over A, and by definition this is tangent of theta. So now we know that sine of theta divided by cosine of theta is tangent of theta. Let's try something else. Cosine squared theta plus sine squared theta equals a squared over r squared plus b squared over r squared, and it equals, with common denominator r squared, a squared plus b squared. But pay attention what a and b are. Those are sides of right triangle here. So by Pythagoras theorem, a squared plus b squared equals r squared. So based on the Pythagoras theorem, this will be equal r squared divided by r squared, which is 1. So this trigonometric identity is cosine squared plus sine squared equals 1. In the formulae pages you will have many more different trigonometric identities that you will be able to use in the future. I want to show you how sine and cosine functions look like. Let's start first with the definitions again. So we have that circle of radius r, and then we have here a and b. I want to remind you that sine of theta, which is here, equals b over r. Now, obviously, when angle theta is very close to 0 here, we will get something like that. And then this side b will be very, very small. So b divided by r, which is here, will be very close to 0. So sine should start with 0. Let's draw it. Let's say this one is theta axis. This one is sine theta. And now it should start at 0. It will go up and then down, up again, and so on. The same thing from the other side. The amplitude will be always 1 and minus 1 here. Now, pay attention that we'll get to the highest value of 1 when this angle gets almost to 90 degrees or pi half. Why? Because that kind of triangle, this side will be very similar to this side, so the ratio will be almost 1, and then when it's exactly 90 degrees, which is here, it will be exactly 1. So this will be that point. So this is 90 degrees or pi half. Now, when it gets further that way and finally gets here, you get basically 0 divided by radius r. So this will be that point, and this point is pi. And then it will go here and be negative, and so on until you get back to the same point where you've been before, and this will repeat forever starting from 2 pi. It will repeat every 2 pi, so you have periodicity of 2 pi for sine wave. Now let's see what happens with cosine. Cosine theta is defined as a over r, which means instead of taking that side, now we're taking that side. For very small angles, that side is very similar to that side. So the ratio will be very close to 1. This means that if you're drawing the same thing for cosine, this is what you'll get. So you'll have theta here, cosine theta. It will start with 1. And then it will go down and up and down, and the same thing with the second side. Again, amplitude here is 1 and minus 1 here. And the period here is again 2 pi. After 2 pi it will repeat itself. So here you have pi, here you have pi half, and so on. Minus pi half. So as I mentioned, the period for both of those functions is 2 pi. Here and also there. But what if you want some function with a different period? We want sine or cosine which will have period of t. And t is some given constant. So how this thing should look like? Okay, let's check and see what happens. So we want something similar, but this one will be sine of something, and this is theta, and this sine will look like that. And similarly to that side, 1 minus 1. But this interval from this point to this point, which is a single period here, this interval will be t. So what kind of formula we can use that this interval will be t? Let's see. All we need to do is just to multiply theta by something, which will be 2 pi over t multiplied by theta. And then this will give us that kind of sign. Let's check why this is true. Let's say theta equals to 0. If theta equals to 0, this is sine of 0, and we get 0 as expected. Let's say theta equals t half. We hope to get here 0 again. So if this theta equals to t half, then this is sine of pi, but sine of pi is 0, as we know. So we will get that point mapped here. How about theta equals to t? So t and t will cancel out, and then you will have sine of 2 pi, which is that point, or proportionally that point. So we basically mapped this point here, this point there, and this point here. If you try something in the middle, for example, let's say t quarter, t over 4. So theta will be equal to t over 4, and then t will cancel. 2 pi divided by 4 will be pi over 2. So it will be that point. It still will be 1 here, at that point, as expected. Now, for cosine, we have something similar. We want it to be like that. And then we want that period. This is, of course, maximum point. We want that period to be t. This will be cosine of the same thing, 2 pi over t multiplied by theta. Let's see why this works. Because, first of all, for theta equals 0, we get cosine of 0, which is 1 here. For theta equals t, we get cosine of 2 pi, which is here. And this is again 1. This is the same point here. Let's try the point in the middle, which is t half. You'll have cosine of pi. But cosine of pi is minus 1. So that's exactly that point.